Okay. All right. Chapter 4 started with just talking right triangles, drawing right triangles, solving right triangles, building our way into the unit circle. But one of the things we talked about was things like SOHCAHTOA. Okay, so go back and remember what we did for SOHCAHTOA. When we were given something like this, solving for a piece of our triangle, we would label what we had, like this angle here. Compared to that angle, 5 would be our adjacent side, 13 would be our hypotenuse. We went through SOHCAHTOA to help us figure out which trig function we would use to write our equation, the one that has adjacent and hypotenuse is our cosine. So we would have set up an equation of cosine of our angle, our unknown problem, is our adjacent over our hypotenuse. We had 3 different styles of this back when we were talking about this in chapter 4. You could have an unknown of an angle. You could have an unknown of the top of your fraction. You could have an unknown of the bottom of your fraction. You know, a slight difference in how we solve each of those. This particular example I have here for us, our unknown is our angle, and that is when we have used inverse trig. Now, your final is all calculator. Okay, all of it. You need to make sure that you pay attention to, because through this semester we have shifted from what we were doing in the beginning, which was all in degrees, to what we did here recently, which was in radians. And you need to make sure that you are paying attention to what mode your calculator is in, that I'm giving you your final, and that you have it in the correct mode you're doing this. This would absolutely be one that would be done in degree mode. Okay. So change your calculator to degree mode. Do your inverse cosine of 5/13. So that might be a note you have to make for yourself is, as you're working through your review worksheet, that you are paying attention to those times where you had to switch the mode on your calculator to be able to get through those problems. Okay. Any questions for me? I don't know that answer. 67 point. As always, we would follow whatever the direction said as far as we were running near full degree. If it's multiple choice, there is no thought process. You just match that to the one it matches to, all of that as we did it. Angle of elevation and angle of depression in the same section, because it is right triangles that are created from this. And remember, the important part was from the horizontal. If there is not a horizontal line involved in that angle, it is not an angle of elevation or depression. And for whatever reason, it's our depression angles that tend to be the ones that we draw wrong. So for an angle of elevation, you must have a horizontal line and go up. This would be your angle of elevation. Typically, then it is like finished off with here, giving us a right triangle. An angle of depression, again, has to have a horizontal line and must go down from that. That would be your angle of depression. Again, typically finished off creating a right triangle somehow, some way. Thank you very much. Remember that an angle of elevation or an angle of depression cannot be here. That is not an angle of a depression. It doesn't have a horizontal. Okay, you have to have a horizontal to be an angle of elevation or an angle of depression, and that is by far the #1 mistake we'll make on angle of depression. We want to just put it at the top of the right triangle. Okay, any questions for me in this category? Would like to see more examples, anything like that? Again, I'm highlighting, so like, could you give me an example or have a question in it? Please ask me. We don't have a lot of examples. Anyone still need this page? We spent so much time going over our unit circle. That is The nice part is when we went back to like solving trig equations, we thought a lot about our unit circle again, but don't forget what we learned. So finding the exact value of an angle, remember that you have the possibility of undefined, if it's like a tangent, cosine, or cosecant. And that comes from being on our axis. Make sure you go back and review your method. Was your method the ham trick? Was your method right triangle? Oh, your special right triangle picture. Was your method first quadrant? Go back and review the first quadrant. Okay. Other things that are just generic to all methods is that you have to slow down and think about your all students Pre-Calc. That you have to think about what it is when it falls on an axis back in our unit circle. Now I told you we were going to get to that. We were going to start thinking in mostly radians. But we did think in degrees at the beginning of the year. Okay, and we haven't thought in degrees of a long time. So that might be something you need to go back and look at. Where does a 315 degree angle fall? Where does a 210 degree angle fall? And what's its reference angle? All of that. And what is that on an axis? So like in degrees, 0, 90, 180, 270, or 360. Or in radians, 0, pi over 2, pi, 3 pi over 2, or 2 pi. That if it were to fall on an axis, we think about that order of pair. How do I get to that dot? Right one up 0, right or left 0 up 1, left 1 up 0, right or left 0 down 1. That all ordered pairs, whether we're looking at an axis or if I'm a quadrant 1 type of person, all ordered pairs go cosine, comma, sine. That tangent is sine over cosine. And then all of our reciprocals, we have to make them look like fractions to turn them over. So cosecant, a secant, a cotangent, make sure you look at the fraction, turn that fraction over, simplify. Okay. So going to these, the top three are pretty basic. The bottom three adds in some things like bigger than a full circle, all of that. But remember, the first job we did, regardless of our method, was drew the angle for ourselves so that we can remember what quadrant was in and find our reference angle. So 7 pi over 6, we have to remember in radians, 6 over 6 would be half a circle, so 7 over 6 we can just pass that. Radians is always easy then to find. Our reference angle of sine is negative in quadrant 3, and the sine of pi over 6, we go to our method, whatever our method is, and we get an answer of 1/2. Negative because we're in quadrant 3. Okay? Cosine of pi over 3, don't forget we can just be in quadrant 1. Your reference angle is pi over 3. Everything is positive in quadrant 1, and cosine of pi over 3 is also 1/2. 4 pi over 3 puts us into quadrant 3 again. 1 more than a half a circle of 3 over 3. But tangent's positive in quadrant 3. And then we have to go through our method, whatever our method is for tangent, sine over cosine, and we should get a positive square root of 3. Our cosecant and an axis problem. So remember that when we were talking an axis negative, heads down first. But 180 degrees is still 180 degrees, so that would be looking at this ordered pair right here. So we are considering the ordered pair -1, 0. Cosecant is the reciprocal of sine, second number in there. So sine 0, if I make it look like a fraction, it's 0 over 1. If I turn that upside down, it's 1 over 0. So remember that 1 over 0 simplifies to undefined, where 0 over 1 simplifies to 0. So we would say our answer is undefined. That if we have something bigger than a full circle, start subtracting full circles. Like this one, a full circle in 6s would be 12 over 6, right? Double the denominator. So if I were to draw 29, 6, one circle would be 12 over 6. If I did another circle, I'd be at 24. 2/12, right? 24 over 6, and I need to get to 29. After I get 24. I need 5 more. So that would put me all the way then into quadrant 2. That's all I needed. I needed to figure out what quadrant I'm in. I'm in quadrant 2. Therefore, my answer is negative. We're doing a tangent problem. My reference angle is pi over 6. And tangent of pi over 6 is square root of 3 over 3. So negative square root of 3 over 3. And same thing for our pi over 4s, bigger than a full circle. 19 pi over 4, a full circle in 4s would be 8 over 4. Another full circle would be another 8, or it would be at 16, which means I have 3 more away. 3 pi over 4 would be in quadrant 2. Reference angle of pi over 4, cosine is negative in quadrant 2. And a reference angle of pi over 4 is square root of 2 over 2. What I did not look at on this page, but you definitely should go back and look at, is when we're talking degrees. Okay, so what is the cosine of 150? We haven't done that in a while. It's finding your reference angle when it's in degrees. Because again, we transition to thinking really in radians. And so it's been a while since you looked at degrees. Go back and look at them. Okay. Any questions pertaining to this? Does anyone want me to draw the special right triangles or quadrant 1 for them? Okay, and then our last topic, which is related to your essay, is graphing our trig functions. Go back, we spent a lot of time graphing trig functions. We did a DCA over graphing trig functions. Go back and look at these. But we have not done this in a long time, right? So first of all, when we graphed our trig functions, we drew 1, 2, 3, 4 tick marks on our x-axis. We then typically adjusted that to the period in our normal trig sine or cosine, that is 2 pi. That your sine and cosine go up to 1 and down to -1. And then we would dot out one sine curve and repeat that process. Sine is the one that starts on your midline. Over to pi over 2 up 1, back to my midline, down 1, back to my midline. This, again, been a while, right? So then graphing our cosine curve, same thing, 1, 2, 3, 4 is just a plain cosine curve, so we're going to go out to 2 pi. Up to 1, down to -1, but cosine is the one that starts 1 above, or your amplitude above your midline. So the starting point would be here at 0, 1, and then we would go to our midline, below, to our midline, above, and repeat that pattern. And that means all the way across our picture. We should never not have a completely symmetrical, smooth curve. We talked about A, B, C, and D in the order in which we attacked those, the order in which we, or what we called these things. And again, remember that this is the topic of your essay. Okay. So as we talk through these, A is our amplitude. It is always positive. It is the distance above and below our midline, or also known as a vertical stretch or shrink. B is related to, but not equal to, the period. Remember that B is going to equal the 2 pi divided by the period. Always 2 pi divided by. Or that we get the period from taking 2 pi divided by B. C is what's known as our phase shift. Opposite of what we see inside our equation. So if it says minus something, we would move right that distance, and that is where our trig function begins. That would be our starting dot for our trig function. A horizontal shift would be another mathematical way of describing that. Go back to B, also known as a horizontal shrink or stretch. But if you had both of these, B and C, you would have ended up with double parentheses. D is our vertical shift. That it is where we move the midline, not just the midline. The entire graph moves that far, but when we were like physically graphing it, that's where we started. We just shifted our midline and then we just made everything related to that. Questions for me on any of that? Okay, that was again a quick overview. Knowing that it's the topic of your essay, I would spend some time going back to, we have a beautiful cheat sheet of all of our great graphs and this on the back side with a lot of things written in there. Also including, which is not in here, remember how we did our reflection and what that did to each of our graphs as well. Okay. Anyone still on this? Okay, so then I'm going to go through a quick overview of the other 4 trig functions and how we graph them. And remember, going through our other 4 trig functions was all based off your denominator, right? We dotted out the denominators, kind of the underlying theme for the other 4. So the denominator of a tangent is sine over cosine. So we would dot out that cosine curve that we just drew on the last page to guide us. To guide us through our tangent graph. So as I dot out my denominator, we really actually only care about the dots that end up on our midline. The dots that are on our midline gave us our asymptotes. And then tangent curves are the ones that were on our midline increasing between our asymptotes. So I would go right halfway up, left halfway down, increase, and we fill that in between all of our asymptotes. Cotangent is the reverse of that because it is cosine over sine. And so again, if we're doing anything other than sine and cosine, we focus on our denominator. I would dot out a sine curve. And again, I really just care about those dots that are falling on my midline. And again, all of those will give us our asymptotes. And your cotangent curve is the one, again, that starts on our midline but decreases. So left halfway up one, right halfway down one, decreasing between our asymptotes. Not something that we really have ever talked about because as we did our transformations, we just rewrote the equation in terms of whatever our denominator was, right? And we applied the transformations to that particular graph, unless it was like a stretch or a shrink of our amplitude, but just a reminder that the period of tangent and cotangent is pi, not 2 pi. And we actually talked about that more when we were solving equations than when we were graphing, because we would add plus and pi instead of plus 2 and pi. It really does not change anything we did if you go back and look at our process for graphing tangent and cotangent. I'll remind you that it required 3 dots, the one on the midline and then the 2 off of the midline, so that you can show the amplitude correctly. The last 2 that we graphed were secant and cosecant, very similar to tangent and cotangent as far as our process. We start with dotting out the denominator. So secant is 1 over sine. So I dot out a sine curve. I will remind you as I'm dotting the sine curve out that labeling our axis correctly was a very important thing. Helped us show that we had the correct period length, that we knew where all of these were, like our amplitude, so make sure that that was on your radar. You have some graphing on the pre-response version of your final, including having to label. Same as tangent in cotangent, is that the dots on our axis give us asymptotes. The difference is we actually use the dots off of our midline to then draw our graph. That is where we center our parabola that goes away from our midline. And you alternate parabolas all the way across your graph. Same thing for secant, but its denominator is cosine. So we repeat this process. Okay, I dot out my cosine curve. I use the dot off my midline to draw in those parabolas away from my midline. Questions on graphing? Okay, so today, first of all, you need to make sure that you are working on chapter 4. Review worksheet A. Yesterday, you should have worked on chapter 8. Review worksheet. All of this is in the packet that was given to you a couple days ago. Reminder that your deadline for all of this is May 18th. I will not accept it late. I do not plan to look at it. Hopefully, we're all just solid in our grades. It will not go in as a grade. Nope, it's not going in as a grade. It will not impact your grade unless your grade is impacting because you have a 92, an 84, or a 77. Yes.